Good evening everybody and welcome to my presentation. My name is Bashaer Alhejaily from Taibah University and the topic of my presentation is Pulp Stones detection using deep learning techniques. The research was concluded by me, Amal Alrehaili and Dr. Syed. I am going to focus on the following points: a brief introduction, background, related works, our dataset and methodology, the experiments and the results, and finally the conclusion and our future work. Today, the aid of modern technology in the medical field can be seen in every respect. Many deep learning and image processing techniques have been applied for timely and better analysis, as well as conclusive results. Dental radiographs are detailed, and some of these details are fine and vague, making them difficult to interpret. In our research, we aimed to detect pulp stones in dental radiographs using convolutional neural networks-based feature extraction followed by multiple classifiers. A brief background: pulp stones can be found in healthy, diseased, and even unerupted teeth. They vary in size from small to large particles and can be seen in the pulp chamber. Figure 1 represented a healthy tooth in the left side and a tooth with a pulp stone from the right side. Why pulp stones? An investigation has been carried to conclude if there were any association between the occurrence of pulp stones and the age, gender, type of tooth, the dental arch, and the status of the tooth. It was discovered that 21.7% of the patients suffering from renal stones had pulp stones, and that a local or systemic pathology may increase the number of or size of pulp stones. Hence, a correlation may exist between local or systemic pathologies and the occurrence of pulp stones. Moreover, the detection of vague objects is primary for the future of dental clinical support systems. Deep learning in dentistry. Deep learning has been used for the automated identification of teeth and their numbering using CNN. Structure identification and segmentation are the main tasks that CNNs have been tested for so far. Also, the first published application for CNN in dentistry was in 2015. However, there is no significant leap in sight. Deep learning has been used for cavity classification, dental implants classification, teeth segmentation, and oral cancer detection. A close related work to ours was with the title of Classification of Dental Cavities from X-ray Images using Deep CNN algorithm. The detection aim was to detect dental cavities. The type of X-ray was panoramic X-ray. The methodology was the use of SOPL method to detect the edges with Deep CNN. Also, contrast enhancement, histogram equalization, and different steps of pre-processing were applied. The architecture used was AlexNet. The dataset collection contained 1,900 X-ray images. The authors concluded that the proposed method accomplished a 96% accuracy for its rate of prediction in comparison to other methods. Our dataset and methodology. Our dataset contained 212 periapical radiographs of female patients from 2019 to 2021. They were selected and converted from RVG format to PNGs. The dataset was divided into two folders, stone and no-stone images. The dataset was divided with the help of radiograph specialists. Figure 2 represents a framework for the proposed methodology. First, the dataset was randomly split into two sets, 70% for training and 30% for testing. Further pre-processing was performed, including resizing the images, transforming grayscale to RGB, and applying the median filter to the dataset. Then each of the two models, the Inception V3 and the ResNet 50, was tested with the pre-processed dataset. By the end of the compilation, the feature labels, in addition to the testing and training, were extracting for each model. Furthermore, we evaluated the model's performance and applied different classifiers to each. The experiments consisted of two phases that differed in the size of the dataset but were identical in the rest of the process. The dataset of the first phase contained 106 images in total, while the dataset of the second phase were expanded to 212 images. The experiment consisted of two phases that differed in the size of the datasets but were identical in the rest of the processes. Table 1 represents the obtained results from applying multiple classifiers to the pre-trained convolutional neural networks models. We started with 106 images, equally divided into stone and non-stone radiographs as our dataset in phase 1. As a result, the ResNet 50 model reached an accuracy of 84% with the medium SVM classifier, while the Inception v3 reached an accuracy of 81.1% with the same classifier. However, with the expansion of the dataset to reach a total of 212 images, it was noted that the accuracy of the two models decreased. So in the second phase, the ResNet 50 reached an accuracy of 76.4% with the medium SVM classifier, while the Inception v3 accuracy with the same classifier was 73.1%. The graph of phase 1 highlights the accuracy reached by ResNet 50 model, which is 84%, and Inception v3, which is 81.1%. And this graph of phase 2 also represents how there were a drop in the accuracy of the models with the expansion of the dataset. However, the ResNet still excelled to the Inception v3 with an accuracy of 76.4%. We were interested in the ROC curve of the second phase since it represented a challenge due to its larger dataset. The ROC curve on the left side of the image shows that the ResNet 50 model incorrectly assigned 34%, while the ROC curve on the right side of the image shows that the Inception v3 model incorrectly assigned 41%. The ResNet 50, as a result, excelled to the Inception v3 since the false positive rate of the ResNet 50 was lower than that of the Inception v3 by 7%. So the ResNet 50 still excelled in comparison to the Inception v3 model. It was noted that the flexibility of the chosen technique was advantageous because the parallel implementation of the different models from the same categories provided a space for observation and alteration. So the enhancement of the models and the choice of the classifiers were easier. However, the needed computational power and the complexity of the models were limited. The fuzziness of the radiographs, along with the vagueness of the objects to be detected, made the classification more challenging and may have increased the false positive rate. In conclusion, we tested and compared the performance of two CNN models, namely the ResNet 50 and Inception v3, with multiple classifiers. This experiment clarified the potential for uncovering the fine and vague details of dental radiographs accurately. For future work, we aim to continue in the same domain and improve our methodology for detecting pulp stones in X-ray images. We aim to increase the accuracy of our methodology by applying enhancements to the model architectures used. Thank you.